So the other instructions, I think, are to find the area of the region between these curves. So to graph these, you could switch it and make it y equals -5 plus x squared and y equals 3x minus x squared, and graph it like normal parabolas, and then you just want to rotate your graph 90 degrees because it's just x and y have been switched. Or you can graph them really quick using Desmos. So -5. So I'm in desmos.com/calculator, and x is -5. I think it was plus y squared. Yep, and then x is 3y minus y squared. X is 3y minus y squared. So there's our graphs. We want to find the area between these two. It's set up to integrate with respect to y. So that means you want to check your limits of integration with respect to the y-axis. So it starts at -1 on the y-axis and it ends at 2.5 on the y-axis. So the integral I want to calculate is from -1 to 2.5. And when you consider which function is bigger, remember you're rotating your mind. You're thinking about the blue function is higher up on the x-axis. Normally when we're integrating, we integrate with respect to x, and then the higher function is the one on the top. But now we flipped our mind and we're thinking about the functions being higher would be to the right, because the equation is now saying x equals something instead of y equals something. So the bigger function is the one closer to the positive numbers in the x-axis. So it's the blue function is the bigger one according to Desmos. So that's this bottom one. So to evaluate the integral, you want to take the integral of 3y minus y squared. And then you want to subtract that by the lower function, -5 plus y squared. And that's, y squared. And then that's dy. Okay, so without a computer mouse right now, but I'll try to type it out. So going term by term, you could combine these. That might make it easier. So it's still the integral. It's 3y. It doesn't combine with anything. We got -y squared minus y squared, so that's now minus 2y squared. And then subtracting a -5, so that's plus 5. So the antiderivative is going to be 3/2 y squared for that first term. It's going to be 2/3 y to the third for the second term, and then it's 5y for the third term. And then if we plug in the limits of integration, the top one is 2.5. We square that. Subtract. Actually, I need to check. Does WebAssign let us? I don't have the question pulled up. So instead of 2.5, I think we need to be keeping a full fraction because WebAssign is sometimes picky. 2.5 as a fraction is 5/2. So I'm plugging in 5/2 instead of 2.5 so I can have an exact answer like WebAssign wants in this one. And this is 5/2 to the third, and then 5/2 here. And then you want to subtract in parentheses the result when you plug in -1. So that's 3/2. And -1 squared is just going to be 1. So that's it for the first term. -1 to the third is going to be -1. So subtracting a -2/3. So we'll say plus 2/3. Then plus 5 times -1 is 5. Okay, so we got 3/2. Then we got 25 over 4. And then we got 2/3. 5 to the third is going to be 125. Then 2 to the third is 8. Then this is 25 over 2. So we got 3/2 over here plus 2/3 minus 5. So let's get common denominators there. That's 6. Multiply the top and the bottom by 3. That's 9 over 6 for that one. Multiply the top and the bottom by 2. So that's 4 over 6. And then the top and the bottom by 6. That's 30 over 6. Okay, and then we multiply those fractions. That's here. We don't need to do that actually. So 25 times 3 is 75 over 8. That's 250 over 24. 25 over 2. Subtracting 9 and 6. Oh wait, we're combining like terms here. So that's 13 over 6 minus 30. So 13 minus 30. That's negative 17 over 6. Boy. Lots of comment. Here we can simplify this fraction, divide the top and the bottom by 2, so that's 125 over 12. The common denominator is 12, I think. That's no, because of the 8. Man, this stinks. Let me pause and see what the common denominator, what this is going to be. So when we get common denominators, add and subtract those fractions, it should be 343 out of 24.